Hi. Okay, 6.2. Let me not move it too much. Okay, so we introed just transformations in general yesterday. The first transformation we're going to look at is a reflection, which again means to flip, right? If I'm talking about a reflection, typically we think about a mirror, right? If we look at ourselves in the mirror, we're looking at a reflection of ourselves. And it's the exact same thing, right? It looks the exact same as us. It's an isometry, right? Because I'm the exact same as my reflection. That's what an isometry is. It creates two images that are the exact same. So a reflection is an isometry. It says it down there. Because again, you're going to just flip something, and then you have the exact same shape. Now, I'm going to point out a couple things here in your vocab. At the very top, it has these rules here that if you would like to memorize those or ask me how to use those on your own, you totally can, but it requires memorization versus we can think about reflections as just an understanding. So I want you to go ahead and look at the line of reflection vocab. So we call the line of the reflection the mirror line. It's the line we flip over. Yeah, so if I have a line right here in the middle and I'm going over that line, right, you can think about it like folding a paper. It's the line we fold the paper on. So the important thing here is that something is considered a reflection if, when I reflect this point over, when I flip it, it is the exact same distance here as it is here. These two lengths are congruent because it's how reflections work. You are the exact same distance away on each side of the line. So you'll notice this distance here is the same as this distance. This distance here is the same as this distance. I should do more lines here, but that's okay. There we go. Whoops, one more. So we again, wherever our mirror is, we are the same distance away from it. Again, same thing here. If I counted like how many feet away I was, if I'm 5 feet away from my mirror, on this side, I would also be 5 feet away, right? Because that's my line of reflection. You are the same distance away. Something else we're going to be talking about relating to reflection in this lesson is what's called a line of symmetry. We know that symmetry, it looks like a mirror image, right? Not all things are symmetrical. Yeah. For example, let me see if I can find an example here. My little guy here is not symmetrical. If I cut him in half this way, notice that this arm curves up and this arm curves down. So if I look right down the center, again, if I'm going this way, it's not the same image on both sides, right? We wouldn't call him symmetrical. If both of his arms flipped up, whoop, and he had a cup in his hand too, then he would be symmetrical because down the center, it's the exact same thing on both sides. Versus a square, for example, we could call this symmetrical across this line of symmetry here, right? Because if I were to fold over that line, it falls exactly back onto itself. That's a line of symmetry. Right there, if I fold, we call that a line of symmetry. Again, not everything is symmetrical. We know for a rectangle, if I try and fold like on the diagonal, well, that's not a line of symmetry. See how it doesn't fall exactly back onto itself? You can see this bit sticking out here, this bit sticking out here. Yeah, that's not symmetrical. It does not fold exactly onto itself. So once more, any line of symmetry is where you can fold over that line and it falls exactly back on itself. We'll be talking about that a bit more in the lesson itself. So to start with, the first three questions here, I know you don't see color in your guys' notes, but you can still, it doesn't necessarily matter actually, as well as I have the color here. So what they are asking in these next three questions, 1, 2, 3, this is all we're going to do, is if it's a reflection. Now again, what this means is if this is my mirror line, every single point on my image, is the same distance away from this line. As well as that, again, just think it through. Reflection means to flip something. So you need to ask yourself, am I flipping it? So let's look at this. This point here, I want you to look at the second arrow and think, what does this point match with on the other arrow? I got the tip of this arrow here. Where's the other tip of the other arrow? Well, those are my matching points. Notice that, bop, 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 bop. Well, that's the distance to my mirror here, but bop, 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 bop. Ooh, those distances are not the same. So it's asking, is this a reflection? Because my matching points here, I could do this for any point, but because these matching points don't have the same distance from my mirror. Again, here's this distance to the mirror. Here's that distance to the mirror. This image is not a reflection. Reflection. Yeah, because those distances are different. As well as that, again, using some common sense. Asking if this is a reflection is asking, is it flipped? No, that is not flipped. It just went burp and it moved. Not a reflection because, again, it is not flipped. Let's go ahead and look at the next one. Now, this one's a little bit trickier because our mirror is a diagonal line. Again, when you look at a diagonal line, it's a little bit, you want to think of it more like this. It needs to be the same distance away from that line. So again, here is this point on our first shape. Look at our second shape here and see if you can tell what matches with that point. Again, here I said these two are matching. What matches with that point there? This is my matching point. Now, here's what's tricky. I need to go straight head on towards my mirror. Dot, 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 dot. Here is my mirror. This is straight head on because it creates a right angle. If I were to reflect over that line, I would flip it here. And then from this point, I would dot, 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 go the same distance away on the other side. I know this looks like it is a flipped image, but again, if it were, this point would go straight over to the other side and end up here. And it didn't, right? It ended up over here. So this is actually also not a reflection. It's something else. It could be something else. Again, reflection is just the first transformation that we learned. And again, the reason why is if I were to flip over this line, it might help you if you tilt your notes. Yeah, so that line is flat to you. Let's see, let's do it that way. Right. Ooh, with the line being flat to us like that, we can see that does not look like a plain old reflection. Something else is going on there. Maybe not just a reflection. So, yep, because this is that distance away, and it should have ended up right there. Not a reflection. Okay, so I want you guys to assess this one. Go ahead and choose any point. I'm going to go ahead and look at this one. Think about going head on at a 90-degree angle to our mirror. Is this flipped over that line? Is it the same distance away on both sides? What do you think? Go ahead and take a look at it. So this point matches up with this point over here. And if I look, again, just based off what it looks like, head on at a right angle, that distance is the same, bop, 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 as that one. And that's true for every point. Here's the distance to my mirror. Here's the distance to my mirror. Those look pretty much the same. So we would call this one a reflection. Each point is the same distance away from the mirror. So in class, we're going to do a little bit more with this. We're going to talk about counting points and doing a reflection on a coordinate grid. That means X, Y's. But it should hopefully make sense. Think about it just like a mirror. You're the same distance away from the mirror on both sides.